Hello, everyone. Thanks for joining today's Masterclass Series Part 4, AI Orchestration. We are extremely pleased to have as our speaker today, ModelOps Chief Technology Officer Jim Olson.
Thank you. And welcome to the final of the 4 in the series on the ModelOp Center platform and how we basically provide ModelOps solutions to a variety of different business needs. I encourage anyone, if you are joining us for the first time, to go back and watch the others in the series where we do talk about the model risk industrialization and model visibility across the enterprise. But today, what we're specifically going to be focusing on this final in the series is basically about how we actually do the consistent deployment of models. So kind of the very end of the journey of the model lifecycle. You know, we've looked a lot about the assessing model risk before you actually get out to production, and once they are in production, kind of what value they're delivering. Now we're going to look at the kind of the mechanics of what does actually deploying a model mean, because it's not one way of doing that. So one of the goals of this is to basically provide a standard methodology of actually getting models into delivering business value. This is not a replacement for traditional MLOps tools and things like that, where you're looking at more kind of the iterative development lifecycle. This is actually mechanizing, moving it through the different stages that it needs to get out to production, and the whole idea is about being able to provide a consistent methodology for doing this that doesn't involve the DS developer of the original model having to get involved, and how do we keep the information there, and et cetera, to make sure that we can provide that consistent kind of deployment. In today's hands-on demo, what we're actually going to be doing is looking at 2 distinct areas. One where we are actually going to look at different deployment types. So we're going to be looking specifically at how to deploy onto a ModelOp runtime, which I'll talk about a little bit when we're in the demo as to some of the unique capabilities that provides, as well as if you have an existing CI/CD pipeline. Let's get real. People already have these. So what does that look like? As well as into just an artifact repository and things like that. And then how are they actually done in such a way that we can have a consistent view across those? As also, how do we, monitor these models when they're out there? Because if you remember, we've talked a lot about this in the previous sessions, but we treat models as a black box from when it comes to monitoring. So we just need to know information about the data. So even if a deployed model is an Excel spreadsheet, making predictions and storing them somewhere and that kind of things, we can still provide that kind of consistent view of the models and how they're behaving or performing, et cetera, on that. So when we actually talk about ModelOp runtime deployment, that's going to be the first item we actually look at. We have our own runtime that runs in a Docker container that, unlike a lot of solutions just wrap it with a Flask container. It can only do REST, and that's it. Instead, we actually have it set up such that you can deploy onto our runtime independent of the endpoint definition. The reason that this is very important is that once you have some model code and you have it reviewed and et cetera, the last thing you want to have to do is go in and modify it to put it in, to switch it from Kafka to REST to a batch mode or any of that. So our runtime specifically provides these endpoint abstractions, such as write the output to a SQL database with a parameterized SQL query, or write it onto a Kafka topic, or read it from a REST and output onto Kafka, or read from Kafka and put into a SQL database. You can do all of those kinds of definitions, including file for like batch, so like an S3, an HDFS location, et cetera, on that. And those can be switched without changing the model. It's actually configured on the runtime or on the batch job. And we'll show you some examples of jobs as we get into the actual deployment process in the live portion of this demo on that kind of things. Because we all love to follow the models about REST and even Kafka and live responses, but chances are within your business, probably a very high percentage of the models, I would say at least the majority, probably higher than that, are actually batch models where they're actually running on kind of a set of data, a fixed schedule, or on demand, or those kinds of things. So how do we actually version and control what models get utilized for those batch processes as well? So we'll be kind of examining that as well. And the ModelOp runtime supports a job abstraction, as well as ModelOps Center also supports a job abstraction of things like SageMaker and other solutions as well that provide those as well. And another example of that would be Spark. It's very typical that Spark would be run as a batch process, and we can capture those, and you'll see how it can be consistent across that job abstraction is consistent across everything from a Spark, SageMaker, ModelOp runtime, all the way down to even things such as SageMaker, et cetera, as well. So we'll be examining that in the live portion of the demo. Then also another case that we see quite often for several different reasons is the idea of deploying the model artifacts into an artifact repository. There's multiple reasons that you may want to do that. Obviously an artifact repository provides a great store for the versioned artifacts, so that you can always get back to a specific identified version if you want to roll back or do that. But then you can also set within ModelOps Center what's considered the current active version that should be used for things such as deployments or batch jobs or those kinds of things as well. But another interesting use case we've seen with an artifact repository is for edge deployment as well, where you actually need to put these out into, for instance, remote factory floors is a great example, where you may have models that are used in manufacturing that actually need to go down to the factory floor. Well, you want to be able to get the specific or the latest version. An artifact repository is a great way to get them out there, as well as all the way down to the point of a device deployment and an end user device. You want some centralized way of making sure you have the exact versions and delivery them to the client over a multiple variety of protocols. So today we're going to actually demonstrate a deployment into JFrog artifact repository, and how ModelOps Center can integrate there to get the model assets out there, and also tie that back into the overall ModelOps Center view, so we can tie performance monitoring, et cetera, even into things just deployed in an artifact repository on that. So, again, it's all about providing the single pane of glass consistent view, no matter how you're actually deploying the models. And that's extremely important to provide. And then we're also going to be looking at Jenkins deployment. A lot of people have a big investment already in their CI/CD pipeline, and for good reasons. Often we want to have a really hardcore firewall. So, basically nobody can push a file from their desk out to production, or even from, non-blessed servers as to which one should actually have that kind of capability and things. And you may want to have a whole pipeline around this that does scans and et cetera and things before it can ever cross that threshold, so to speak. So, by integrating with Jenkins and allowing us to basically push information into Jenkins and execute Jenkins jobs and tie those back to the original models, it really gives us that power for you to do whatever you want within your enterprise. And often, as I said, these processes already exist. So it allows us to provide that overall solution, monitoring, et cetera, without having to come in and rip and replace. We can do that. And it really does give you a lot of flexibility as well, because the reality is there may be a bunch of transformations or things where you have to do kind of some Groovy or some other items on there to update other items that go along with this, and make sure that it all happens in lockstep. And obviously Jenkins has been doing this for quite a while, and people have been using it. So we want to provide that kind of integration. We'll show you what that looks like and some of the steps that you can do to define your own custom Jenkins jobs, and how that integrates with ModelOps Center and how that shows up within ModelOps Center as well to do that. And one thing I will point out is this also, we're going to show them separate today just for clarity. but often we would do something such as deploy into an artifact repository and then potentially have a Jenkins job triggered that would actually pull from the artifact repository just for consistency of deployment. It's absolutely not necessary. You can come directly from our system to that, but that's a common pairing we see, so I did want to point that out. Then finally, we're going to briefly go through how you can actually set up, now that you have a deployable version of a model, how do you actually go and apply monitoring to it, and what does that look like? We've already looked at in the past how we can create exception reports into Jenkins automatically, into Jira automatically, and have those kinds of things tracked and make sure that issues are resolved. I want to briefly walk you through what that looks like and show you really how flexible it is that any kind of a standardized test that you run, including your own Python code that you may already have, can actually be turned into a monitor. And we'll talk about the difference between those two a little bit there. And then that information, as we've previously demonstrated, can actually be extracted from those results and put into Word documents and then forever associated with the model. So, if an exception occurs, you can capture all the details, including any resolutions, and then actually have that associated back to the model itself, so that you can actually ensure that the situation has been resolved, documented, etc., going forward. So again, we're going to look briefly on those areas, but I do want to concentrate around the deployments and specific today, and what those different items look like within the ModelOps Center system, and then how we actually manage that. And more importantly, how we're going to see in the long run, they actually kind of all look very, very similar when you actually look at the model, which is important because that's what we're trying to provide again, is the overarching goal here is that consistent view, consistent monitoring, consistent single pane of glass into all of your models, and how they actually interact with that. So now we're actually going to switch into the live portion of this demo. So give me 1 second to hit the screen share there. And all right, here we go. Okay, so again, this demo we're going to be showing you today is on the version 3 of our product, which was just, not quite as recently released now, but it was released at the beginning of the Masterclass series. And so everything we're doing was within that version 3 goal. So you'll notice here, I want to point out as we go into this, remember, one of the goals of adding the monitoring and et cetera is to be able to populate these kind of dashboards of information about what is actually going on with an individual model. So, you can see here, there's input volume, concept drift, and et cetera. I will remind you that those are also associated with decision tables where you can specify the limits and the metrics, et cetera, as to what these individual goals, et cetera, are. So, when we're doing these deployments and we're doing these monitors, the goal is to get this populated in the long run, where we all get to look back at it and have that information, as well as the details about what has been going on that. But what we're going to start out with today is we're going to, remember, these are our model life cycles that are actually definable by you. We're going to take a very abbreviated one today, where we're going to show how the exact same model can be deployed in all, in 4 different ways. So we're going to start out with a ModelOp runtime, where we're actually going to actually deploy the model as serving on a REST endpoint onto one of the ModelOp engines, and actually review what that looks like and how that gets out there and how it serves. And then what we're actually going to do after that is we're going to actually deploy it out to an artifact repository. In specific, we're going to put it into a PyPy repository as well as a generic repository. So we're going to put it in 2 places to actually take a look at what that looks like and how that process occurs, as well as then we'll actually deploy it as a batch model. So that would be used for a future batch run, and how we can view that. And then finally, we're going to actually go through and take a look how we can create a Jenkins job that actually we'll pull information and pull the model directly from ModelOps Center and deploy it. For today's example, we're going to do the same thing. We're going to deploy it back onto a ModelOp engine, but rather than using a model lifecycle to do that, we're going to have a Jenkins job actually orchestrate that entire process on that, and how we actually can track that job abstraction and ensure that it's complete and associated back with the model itself. What we're going to actually do, again, these are model life cycles. They are actually developed in standard BPMN notation. And what I've actually done is created branches. So we're going to use something called tags today when we create a new version. And just for the brevity of this demonstration, we're not going to do reviews, et cetera. Typically, what you would see in this kind of a model lifecycle is perhaps we would move it to a staging environment or a pre-production environment. You might have some approvals or reviews in line where a ticket is created and we don't proceed until we do that. But especially where we're going to go through 4 different styles of deployment today, we wanted to make sure that we got through it and we're not walking you through deploying a model and moving it to stage 4 different times. So what we're going to do is just immediately when a new version of a model is registered, we're going to immediately fast track it to one of the 4 different deployment methodologies. And we're going to do that utilizing basically a tag to tell it which path it should actually take. So we're going to start out today. Let me bring up another window so we can switch back because all these happen really fast. We're going to go grab a business model. So we're going to grab basically a German credit risk model. So we already have that defined within our system. You can see it's actually already being monitored and run in a different instance, and we have multiple snapshots. To us, a snapshot is a version of the model. So it's once you take a snapshot, is considered immutable. You can't go change anything that's within the core model at that point. We can create new associations, which we will actually do, where we can add new monitors to it and things like that. But the core model itself will not be allowed to be changed at that point on that. So we can see things. You'll see how we do capture information here as well about what's gone on with the model. So we'll see more of that actually kind of fill out as we go along. So let's go ahead and we're going to actually just, as I said, create a snapshot, and we're going to get this model deployed over onto one of the runtimes. I'm going to show you this briefly as well. So you can see here, we talk about a ModelOp runtime. We can see that we have a series of them here available within my demo environment. We can see that specific engine 1 is actually basically running a consumer credit approval model, and then we're actually going to be deploying onto engine 2 in this case. So I briefly wanted to point out a few capabilities of the ModelOp runtime engine because they are unique. You'll notice here that it actually has the ability to specify endpoints on here. So we can actually look at how it's actually done. So in this case, we have this one actually listening to a Kafka topic and outputting the results back on a different Kafka topic. And you can see here that it specifically is going to the topic of loans on that kind of things, and it's actually doing that, and we can actually define these and change these without touching the model code. So that way, when it's actually executing on there, we can see the effects it's having on the system. We can see the number of basically items per minute going on there. I have a random generator that's basically populating onto this Kafka queue and actually capturing some of the information. But you can see, and what we'll be showing is you'll see the different paths it's going to take to actually being deployed. Here in this case, we actually deployed to using an initialization process that actually kind of primes the pump for the demo. But in these other ones, you'll see how we follow the different paths. So we'll be able to see the difference between when we deploy direct from an MLC versus when we deployed through Jenkins. And you can also see we're live capturing the logs. So that just gives you an idea of what we're going to see as we actually deploy these items out onto the runtime. So you can see the engine 2 is sitting in a init state. So if we go back to this model here, we're going to actually fast track this one right out to deployment. So we're going to create a new snapshot. I'm going to add a new tag on there of deploy ModelOp. Now, these tags are flexible in that they can be used for a variety of purposes, but one of the reasons we have those is to be able to associate different paths within the model lifecycle that it should take. We can key off of things such as model type or the service destination or all other kinds of things. But in the case of demos, it works really well for us to be able to use these tags and specify those and key off that. So that's how it's going to know which path to take. So we're going to keep changing these each time we create one to take those different paths. So that's actually what's going on there. So now when we actually go ahead and click next, we're going to specifically tie it to the application prod engines. And then we're going to actually say, okay, create it. Now, when we create the snapshot, it's immediately going to start down that path. So you'll see now it's actually going out. It's actually deploying out onto the ModelOp engine. It's putting the code onto there. The ModelOp engine will reach out to our services and get the exact version of the model that's going on there. And we'll then kind of capture those results on that. So we're going to go ahead and take a look now. If we refresh this, we should see that, sure enough, we've actually been deployed to the German credit risk model on there. And when we go on to that, we'll see that it's actually running, and that we can see the REST endpoint that we actually got deployed onto there. So we have basically with the same model code, no matter what we're actually utilizing there, it'll respond to those different protocols. So we're tied to REST. It's listening. There's our actual endpoint we're actually listening to on there. It says synthetic because that means it's a round trip. You could actually take REST and output to something else on there. But we can see in the live view that now it's sitting here, it's ready. But like I mentioned, we're catching lineage about the model and how it actually got here. So when we come to understand, hey, how did this model end up on my production system? Well, here, it actually took this exact path and is done through this. Now, obviously, this is a short path, but you could see if it had gone through staging and prod and et cetera, we'd be able to actually get back all the information, as well as we can see all the details of the individual items. I do want to mention that the ModelOp runtime also respects requirements.txt. So if your file has specific libraries that it needs, we can actually dynamically down those either from a private PyPy server, which would be our recommendation internally with approved libraries, or even from the internet, which we don't recommend on that kind of thing. So you can provide kind of a control of what libraries actually get in those, as well as have those libraries pre-bundled within the container if you want to, and not allow any external access. But then we can tell you specifically when it's loaded that these dependencies were not satisfied. So we really can provide a lot of that kind of level of detail on that. So you can see now how we were able to basically automatically create a version from within our system and actually publish it out to one of our ModelOp runtime engines. And, that's the very typical kind of path you would see with most of these kinds of solutions. So now I want to show you a different kind of path here as opposed to that. What we're actually going to do, just to clean things up, because we're going to actually redeploy later on this, I'm going to go ahead and actually undeploy this model and get that engine cleaned up so it's ready to receive another one. So you can see where we've actually cleared that out now. Now another, as I said, form of the other path we want to do. And you can see here this version, once again, we captured that information about where it is. And you can see where it's actually active. It's probably not going to show now because I just took it off. We would have seen it deployed here as well, but I showed it to you on the other screen, but I just undeployed it. So you can always track where this version is deployed as well. We'll see that in a second on the other one as well. So now instead of deploying this model to an actual runtime, we're going to take a step back instead. And actually, this is a standard instance of JFrog Artifactory. I have a couple different repositories already set up just to show you how we can deploy to different items. So, we're going to have an actual, basically their standard one they give you that's a generic repository. And then we also have a PyPy repository. Things like Artifactory and stuff. When you go to actually create a repository, there's quite an extensive variety. From our standpoint, when we deploy into these, we can deploy into any of these that actually is served. So you can serve off an NPM or a Docker image or, Puppet or Chef, any of those kinds of things that actually supports on that. We can support all those different types. But today we're going to focus on a generic for if you were just creating a Jenkins job and just wanted to grab an artifact, or a PyPy server if you actually wanted to use pip to actually install your model within a service providing that. So we've got, back to here, we've got these two repositories. And again, so we're going to take that same exact model and we're actually going to follow this path to actually deploy it to both of those repositories just to show you the flexibility we have there. So to do that, we're going to once again create another version in this case. We're going to, instead of deploying to ModelOp, we're going to deploy to Artifactory. Okay, make sure I type that correctly there. So now we're going to go ahead and do that. We don't actually need to select an engine in this case. And when we do that, we're going to create that snapshot. When we do it, we'll see it actually goes out. I think once again, it's going to follow that other path. And it's actually going to deploy to both of those artifact repositories. So now if we go out and look within the Artifactory, I'm going to refresh here. On that, we will see, come on, JFrog, there we go. We will see that, sure enough, like within our PyPy server, we now have deployed the entity within there. Sorry, concentrating on this. And basically what we do is we will automatically take all of the items that are identified as runtime components of the model, and we will actually bundle those up into a tar for you on that. And you can see all of the items that are required to actually run that particular model are now registered within a TGZ format, which is, you can do that or wheel. On that, and are actually within the system. So we have that. Likewise, we can publish that same tar.gz into a, sorry, it's a little slow on expanding here, into a generic item as well on that. So we have that in there. Now we'll see if it's actually updated or not. Yes, it did actually. Sometimes it's a little slow in capturing that. You can see where we've actually captured a couple different versions of the model within here, within the system that we have. So we have our 10.1 version that is actually in here. We pulled all that information directly from the model metadata into our system and then use that delegate within the life cycle to publish into that. So now we could actually go and do a pip install from anywhere to actually pull from this by pointing it at this artifact repository. So, that could be used, for instance, on a factory floor to say, get me the latest model. I can pull that back from a centralized PyPy server to do that, or more importantly, tie myself to a specific version of the model or grab latest. So this is a great methodology of actually getting your kind of the control around the metadata and monitoring of your models, et cetera, while actually also being able to have a distribution methodology that's more standardized and doesn't rely communicating directly to ModelOps Center. So while we're on that topic, I do want to point out to you, even though this is deployed to an artifact repository, so it's not quote unquote running anywhere, it's actually usable by people. So, we can actually add monitors to these models because, again, we treat everything as a black box. So when we want to actually add a monitor to a model, we can go in there and we can actually select from any of our out-of-the-box model monitors. They could be monitors you registered with our system. They just need to be Python, R, C, whatever we can run on that kind of things. And then you do that. And we call these standardized tests. Because basically the idea of a standardized test is it will actually go out and run a standard statistical analysis based on a variety of data. So for instance, if we want to do a data drift monitor for this particular monitor, we can actually choose that on that, and it'll grab the latest version of that from our system. And then we can actually basically tell it where we actually should grab those references from. I want to remind you, we don't store the model data within our system. Instead, you tell us like the SQL query to make, the S3 bucket location to pull it from, et cetera, on that kind of thing. So basically, when we look at this particular model, it'll tell us, it wants basically a baseline data and a sample data. We have a couple predefined S3 locations for this model that I put in here for convenience on here of that tells us where it is. So this is actually an S3 bucket telling us where we should look at that for. And then we can also then add on, for instance, where the most recent sample data should actually be located. And again, these are not within our systems. These are S3 locations that are updated. It could be a pointer to a data warehouse with a SQL statement, et cetera, to pull it. It could be an HDFS bucket. It could be, any of those kinds of things. We just need to know where to go get it to actually put that information on that. And then, of course, the little screen share thing is blocking my next step. There we go. And then, we could actually then dynamically specify thresholds either through an existing asset, or we could actually create one of these DMNs that we actually already have here, or we could actually edit our own and add a new one, that kind of thing, so that we have that. And then finally, what kind of turns that standardized test into a monitor is we can actually add a schedule to it where we actually can trigger a process. Typically, we fire a signal is what we call it, and we actually start a whole lifecycle process that would then run the associated model, scan that DMN, and then analyze it and create the exception report if needed as well. And again, this is done on any version of a model. And we just walk you through this whole process, and you actually have that. And once you save that, then it's associated with that version of the model, and will begin to execute and allow you to basically perform the monitoring of that model. So even though it's just deployed in Artifactory, we can still set up monitoring on that to see how it's doing on a variety of different data sets and have those kinds of associations pre-configured on there. So I do want to get on to the additional deployment methodologies there. So we're going to actually go and show deploying as batch. That one won't take long at all because basically it's very, very simple. What we're going to do is actually go ahead and again, we'll create another snapshot and we'll actually instead deploy the Artifactory, we'll deploy as batch. And again, what that means is that this is the model that should be used for any of the batch runs for this particular model. So we're going to go ahead and create that snapshot, and that one's going to happen really fast. So you can see where we've actually done. It's deployed as batch. So now if we look back at that, this particular model, we're going to see, yes, it's actually deployed to production. Will run on Engine 2 and actually run as a batch. So when any of these scheduled jobs come in, they could be triggered by cron, by us, by manual, by manual request, etc. on those, and it will know to actually grab this model and this exact version for any requests that come in on that engine for this particular service. So we have that. So you can see where we actually track that. And then kind of for the final one I want to show you here today, I want to show you, again, how we can actually integrate with Jenkins. So let me bring up our Jenkins instance here. We'll go, it says just standard Docker image of Jenkins that's running out here. We basically will be able to schedule jobs onto this Jenkins queue. What we've actually done is created a demonstration job here that actually takes parameters that we'll send from that model lifecycle about the model to actually execute the process. Sorry, Jenkins is being slow. There we go. Jenkins always seems to be a little slow. Sign in there. Come on, there we go. So you'll see we've actually created a deploy Jenkins job that's specifically going to take the information about the model and deploy it out there. So to give you an idea of what that actually looks like, you'll see that we actually have, in this case, what we've done is develop a Groovy script that will play it. So we're going to pass in the model ID and actually get it directly from ModelOps Center and push it out to one of our engines and actually deploy it here. So, we can do that to just show you the ultimate flexibility. As I said, we could use more traditional techniques and use like the artifact plugin, artifact repository plugin or others, pull it from there. But I kind of want to give you the overall view of what this actually looks like. And we're actually going to track this within our system. So we're going to go ahead and actually create a new final version of this one here. Instead of deploy batch, we're going to do deploy Jenkins and actually fire that off. And then we'll get one more step and we'll go ahead and create that snapshot. And now what you'll see is it's actually going out. It's actually going to go out and launch a Jenkins job. So, we're all familiar with the job abstraction within Jenkins, but ModelOps Center also has its not only live runtimes views, but live jobs views where we can actually see different kinds of jobs. So you can see we've had some of those monitoring jobs going in the background, but we also have a Jenkins job abstraction. So we can actually track what's going on here. So we can see that it's actually running. It's starting to execute a command over within the Jenkins. It's launched the job. It's executed. We're capturing all the output just like if it was a transform job or any other kind of things that actually happens within those systems. And we'll capture the status as well. So, this job is going to be tied right back to that version of the model. So we'll even see the deploy job that actually occurred with that model, as well as other items. So you can see that now that job has been complete. And in fact, if we go over and look at the runtime, now you can see that the German credit model is actually running over on that runtime now, deployed through Jenkins rather than deployed directly through our system. Likewise, we'll get the information again about how the model was actually deployed there. So we can see it took that Jenkins path, and we can see that it's actually deployed over in production inside that engine 2 again, as well as we do have the job. There's our Jenkins job that actually did the deployment all through the single pane of glass of basically into the views of everything that's gone with this model. So that's really the whole idea of these AIO solutions, is that we're really looking at, giving you those insights to the models as to how they actually have been used, how they got deployed, what versions you have, where are they running, et cetera, and then getting you back all to that overall dashboard about what's actually running out there and how has it actually been utilized. So you can get all of that kind of information within the system and have this inventory, this kind of greenfield inventory of everything that's gone on with the model, how it was used, who did what, et cetera, and have that consistent methodology for deployment. And we really feel that that's a unique solution within the industry to actually be able to be that conductor of the orchestra, where we're literally tying together, this happened to the model over in ServiceNow, this happened in Jira, and the Jenkins job was run on it over here, and a SageMaker job was run over there, and really giving you that single view. So I hope I've been able to really give you a glimpse into what we're doing there and a little bit of details about how we really can orchestrate these AI models and move them throughout the business and still tie all that information back together and continue to monitor the health of those models as they go on. And want to think. So I want to save a few minutes here for questions. I see we have a couple different questions here. I see one is, can you walk through an example of how you would add a vendor-delivered model as a use case, as mentioned in the video on your website? Absolutely. Again, because we have such a flexible definition of a model, we can even call just a use case model. So let's say we have zero access to the model. It's running as a RESTful endpoint that we're consuming from a SaaS type situation. We can register that, we can capture the information about that, and obviously tie any of the things you've seen back to it. Now, in specific, if we want to monitor it, depending on the kind of monitoring, we would require a couple different things. Now, for something as simple as concept drift, obviously, you couldn't be storing the output somewhere, and we can run on that with no participation from the vendor. If we want to actually look at like different kinds of more data drift analysis, the vendor would have to provide some baseline data for it, or you would have to create that yourself, maybe with a prediction and a score run and et cetera, and some information about how you trained it, perhaps if you trained it, et cetera. So depending on the kind of monitoring you with things, it'll require different data sets to be available, but we do not need the model. We just need to say, yeah, a model exists at this location. We're not going to call it because we do a black box approach to it. We actually can just deal with those associated data sets. So that's how we would view it. You would see it within our system, and you could even register the endpoint as the currently active endpoint. So let's say they versioned their endpoints. So you could say, yeah, currently we should use the V1 API endpoint, but in the future we can call it the deployment of V2, much like we can deploy something to our factory and say that version 0.10.1 is the current version of the model. So that's how we would typically handle vendor models. And again, it depends on the level of vendor participation as to what kind of monitoring you can do. If we don't have the training data, we don't have the training data, and that does potentially limit some of the kinds of analyses we can do. And then can you walk through an example of how you would include a spreadsheet-based model? Sure. Yeah, a spreadsheet-based model, it's really like, for instance, earlier in the presentation, actually, I'll go ahead and share my screen here real briefly again and show you an example of an Excel spreadsheet inside of ModelOps Center. So, again, we treat models as very generic. So, for instance, in Excel, I actually implemented a logistic regression within an Excel spreadsheet, and the Excel spreadsheet itself has parameters within it. So when we look at the assets of the model, is that we have a very broad way of being able to capture what the definition of a model is. So here you can see where we have the actual spreadsheet and version. It's sitting in an S3 repository in this case. That could be an artifact repository, others, et cetera, where people would actually capture that model and pull that in and use that. And that would be the current blessed spreadsheet. Now, whether that spreadsheet is auto-executed or it's the one people currently go get because it's sitting out in S3 and everyone just uses it from there, all the parameters and et cetera would be contained within that Excel spreadsheet. But once again, we can add monitors to that if we know input and output and have locations where that kind of information is being captured. So, we really can handle almost any kind of a model that you can come up with that's available within the system, because we put a lot of thought into what is a model. Everyone loves to talk about the AI models and things like that, but most of the models really being used out in business are traditional logistic regressions, or maybe even just a decision table, or as I said, an Excel spreadsheet. So we can represent those within our system, and as long as we have data we can deal with, we can where we know input and output data locations, we can actually go and do that. Do we actually execute the spreadsheet models within our runtime? No, we don't do that, but we do register, version, control, et cetera, and can potentially monitor them as well. Well, we're right up against the end of the hour here. So with that, I want to really thank you for joining us today in the final in the series, and I hope you enjoyed them as much as I did presenting them. So thank you again for your time and for joining us.